One of the interesting things you could do with Traveling Salesman Sketchpad 1.0 is to study different tours. So here's a tour created by what is called the farthest insertion algorithm. And what you could do here are basically three replicas of that. What you could do is you could study what I call the isopermutation regions, isoperimetric regions, and isoarea regions. So let's just see one of them so you can see what this is. To be able to do that, and the idea behind it is, as I move a particular node, you're going to notice the rest of the tour updates also. So what we do is we call this node that I colored in green the isomorphism probe. So this is the only one that is allowed to move here. What I can do is I can select the region, and within this region, I'm going to ask the question. So let's construct equal permutation regions. The resolution, let's make it 1, see how long it's going to take. 12 seconds, we can afford it. And what it's going to do is it's going to generate all the regions in which the tour is going to have a particular permutation. So within the green region here, as you notice, the ordering of the tour doesn't change. But the moment I go into this pink region, the tour updates, etc. So here is what is called the isopermutation regions. As you switch from one colored region to another, the permutation of the tour changes. But within a particular colored region, the permutation is the same. What I'm noticing is, let's actually change the color of this tour to something hopefully more visible. Let's make this green, or maybe blue. And let's make that one red so we can see it better. So what I'm going to do is I'm going to do the same thing here. So this time it's going to be the isoperimetric regions. So let's set this to probe. Let's select here a region of interest. And let us construct this time the equal perimeter region. It's going to ask me the resolution. Let's make it 1. It's probably going to take a little bit of time. The bandwidth, if you make it too small, it's hard to see what's happening. Maybe let's make the bandwidth 10 for right now and see what we're going to get. 12 seconds, we can afford it. And just like in the case here, there's going to be some colored regions. As the probe node moves in that colored region, you maintain equal perimeter. But as you go to another colored region, the tour updates and then the perimeter jumps. And let's do the same thing for the area. I'm going to set this to probe, isomorphism probe, and then select the region, construct the equal area regions, resolution of 1. Let's have area resolution bandwidth maybe 50. Maybe we could do this a little bit. So bandwidth of 1, resolution value of 1, but bandwidth of, let's say, 100. Okay, and 30 seconds, yes. And what we're going to see is a counterpart of that. But as the probe moves within a region, colored region, the area enclosed by the shape is going to be the same. However, you're going to notice after that, it's going to be different. Observe, this is a pretty complicated diagram. We could have probably changed the, and you can see within the equal area regions, the equal permutation regions also, because you can see these disruptive changes from one region to another. And this is where the project starts having some interesting artistic implications, because you have these really wildly intertwined regions with all kinds of interconnected features.